Alright, John, so there's only one more question left on this part, which has to do with the area of a triangle. Then there's the homework assignment, and then you're halfway through this chapter. So really easy stuff. Alright, the area of a parallelogram, and I'm just going to stop you right there and say this chapter is supposed to be on finding the area of a triangle, and now they're talking about area of a parallelogram. So it kind of confused people to begin with, but I'm going to show you why this applies. The area of a parallelogram is 20. Find the measures of the angles of the parallelogram if the two adjacent sides, and adjacent just means next to each other, so if the two adjacent sides are 8 and 5. So let's just think about a couple of things, couple of properties of a parallelogram. Number one, if I draw a line right down the middle of this parallelogram from corner to corner, then I divided that parallelogram up into two separate triangles. So the reason why this is in this section is because the area of a triangle is 1/2 AB sine C. So if we want to find the area of a parallelogram, which is essentially two triangles put together, we're pretty much taking this equation, area of a triangle, and multiplying it by 2. So if I take this triangle, this equation, and I multiply it by 2, well, the 2 right here and the 2 in the 1/2 cross out. So to find the area of a parallelogram, it's pretty much the exact same equation, except for we just eliminated that 1/2 right out front. So the area of a parallelogram is AB sine C. So you can use that equation for parallelograms as well. Let's also talk about a couple other properties about parallelograms as well. In a parallelogram, the sides that are opposite each other are equal. So if this side is 5, I know that this side is 5 as well. If this side is 8, then I know that this side is 8 as well. Now let's talk about the angles of a parallelogram. The opposite angles of a parallelogram are equal as well. So this angle right here is equal to this angle, and this smaller angle is equal to this smaller angle. Okay? So let's read the question again. The area of a parallelogram is 20. So I already know this part. 20 is equal to. Find the measures of the angles, so it wants us to find both angles, of the parallelogram if the two adjacent sides are 8 and 5. So let's just take a look at the, well, I was going to say the little triangles, but we're not doing that. We're looking at a whole parallelogram. So the same concept is true, though. You need to use angle or side, angle, side. So let's see. Let's do side 5 times 8. And that's going to be sine of C. Okay, so I'm going to do 20 divided by 5 times 8, which I know is 40, but 20 divided by 40, that's 1/2, so sine of C is equal to 1/2. I don't care what C is, I don't care what sine of C is, I want to know what C is. So second sine, second answer, and hit enter. C is 30 degrees. Go back up here, so C is 30 degrees. But it said that it wanted to know both of the angles. Well, the other thing that we know about a parallelogram is that this angle and this angle, they add up to be a total of 180 degrees, and I'll show you how. If I took this angle right here, I'm going to try to do this as best as possible. If I took that angle right there and I moved it over here, you see how those two angles, they line up to be 180 degrees? Alright, they are called supplementary angles. Supplementary means add up to 180. Complementary means add up to 90. So because these two angles are supplementary, if this one is 30, this must be 150 degrees. That is definitely going to help in, I think it's the next section when we start talking about law of sines, but just so that you know, they add up to 180. Also, here's just a little bit of a hint that I can tell you. I know that you just finished the section on trig equations, and the hardest part about that was getting down to the end, and when it said sine of an angle is equal to 1/2, the answer wasn't just 30 degrees. You had to look at where sine was positive. All students take calculus. And because sine was positive in two different quadrants, in the first quadrant and the second quadrant, you had to not only say, all right, it's 30 degrees, but it's also 180 minus theta, or 180 minus 30, which happens to be 150. Look right there. That was the other answer. And the reason why it works is because when we use this equation, remember how we said that it has to be side, angle, and then side? Well, look, we have side, angle, side. That was 5, an angle, and 8. But if you look over here, this is also 5, an angle, and 8. And that's why parallelograms are so cool. So we could use sine to figure out both of those angles, and both of those angles are the angles of our parallelogram, which is pretty cool, huh? I know, I probably think it's cooler than you do, but that's okay. Okay, so that was it for that section. That was the notes on the area of a triangle, and this is homework page 466 to 467. This is homework number 101. All right? So hopefully you're feeling pretty good about this stuff so far. I don't think that these concepts are that horrible. I am going to go through the practice, that worksheet, homework number 103. I am going to go through and do those problems with you after I finish all of these sections, just because I want to make sure that you have enough practice with these things. Also, while you're doing these homework assignments, if you ever want me to email you or send you the answers to the homework assignments so that you know if you're doing them right, I am completely happy to do that, or make copies of them and give them to Abby, okay? So let me know. All right, let's move on to the next section. Okay. Now we're going to talk about law of sines. Now I want you to go back to your reference sheet, oops, which I apparently closed. Okay, so we know about the area of a triangle. We know about law of cosines. We know about sum and difference of two angles. We know about double angles and half angles. Now we're getting down here, and we're going to learn about the law of sines right now, okay? So let's move this over. Okay, law of sines. Divide each of the possible area formulas by 1/2 ABC. So if you look right here, these are all the same exact thing as the area of a triangle formula. See, 1/2 AB sine C. That one's right here. And it's exactly the same thing that we dealt with when we were talking about law of cosines. Remember how I wrote out all three of those different formulas, and I said that, you know, you can interchange which sides and which angles you use as long as that A stays the same as that A? Well, it's pretty much the same concept. We're going to take the area of a triangle and we're going to rewrite it three different ways. So this time we used sine of angle C, that time we used sine of angle B, and that time it's sine of angle A. All of these equations are all equal to each other. It's just three different ways of writing it. Okay, so that's why we have equal signs in between them. Now, what we're doing here is we're going to derive the law of cosines. I'm going to show you where it comes from. If this is confusing to you, then just ignore this, forget about it, but I'm just trying to show you where it comes from. Okay, so those are all equal to each other. And what I'm going to do is I'm going to go through and divide every single one of these terms by 1/2 ABC, and we're going to see what happens. 1/2 ABC. Okay, so now it's the fun part, we get to cross stuff out. Well, there's a 1/2 here and a 1/2 here. I have a B and we have a C. So this whole equation becomes sine of A, sine of angle A, divided by side length A. And that's equal to. Let's cross out some stuff over here. Goodbye 1/2. I see 2 A's and I see 2 C's. So sine of B divided by side B. And the last one, goodbye. See you later. Adios. Okay. Sine of C over side length C. Okay. So what we did was we just derived the law of sines, and the law of sines is on your reference sheet. It's something that you do not need to memorize yet again. And at this point you're probably saying, all right, Ashley, you're insane, because this equation says sine of A over A, sine of B over B, sine of C over C. And this one says A over sine of A, B over sine of B, C over sine of C. Well, it doesn't matter. It doesn't matter if you read it like this, it doesn't matter if you read it like that. Whichever one that you are more comfortable with, it's exactly the same. All that we're saying is that there's this really cool, unique proportion that exists between, like, within triangles. So if I draw a triangle for you, law of sines is saying that this is angle A, BC, and this is A, B, C. Law of sines is saying if I take the sine of this angle and divide it by that side length, you're going to get some decimal. And that decimal is equal to if I take the sine of this angle and divide it by that side length. And you're going to get the same decimal. And then that decimal is equal to the same thing if you take the sine of this angle and divide it by that side. Which is really kind of cool, because whatever, you know, that decimal, that proportion is going to change for every triangle, but because we know that they're equal, you can use this information to solve for missing angles, to solve for missing sides, to solve for a bunch of really cool things. Okay? So whichever way, this is the way that's written on your reference sheet. If you want to use that, that's perfectly fine. Or you can use it this way. You're never going to use all three terms at once. You're pretty much going to say sine of A over A is equal to sine of B over B. And then you're going to use those two and cross multiply. Or maybe sine of B over B is equal to sine of C over C, cross multiply here. You're never going to use all three, but they just write it out for you because to tell you, to emphasize the point that they are all equal. Alright, so I'm going to stop right here, and then we're going to do some questions together.